So Rachel was an undergraduate here and graduated in 2008, is that correct? And then went and did a couple of years at Washington University in St. Louis, and then ended up coming back to Georgia Tech for her master's degree, which she finished in 2011, is that right? And then Rachel worked professionally at Niles Bolton, and that's in the office. Worked for Niles Bolton for a few years here in town, and then ended up coming back and working for me professionally in my practice. So I've had the pleasure of seeing Rachel grow and develop into really a cutting-edge leader in design thinking and design education. After she left us, we tried to keep her for as long as we could, but after she left us, she went to Harvard, went to the GSD, and did an MDes in a dual degree in technology and art and design in the public domain. So it's a very interesting kind of space of inquiry. How is technology integrated into design and art and all that, the kind of impact on the public domain. I think that's what she's going to be talking about today. I'm not exactly sure what she's going to be talking about, but she's got a very provocative title for her lecture. And so with that, I'm going to turn it over to Rachel.
Thank you. It's great to be here, and it's great to have this new facility. I think having it in the kind of former architecture building where all the late nights were, I might have had a bit of PTSD giving a lecture in that building. But so it's good for alumni coming back to a new facility, that's for sure. So today, under this kind of topic of unconventional practice, mainly, as Tristan mentioned, my practice has been mostly a research practice, but I'll talk a little bit about more of a opportunities of acting as somewhat of a consultant in terms of material and machine knowledge and architecture. So throughout the course of the lecture, I like to kind of point out how the way that I work, and that has to do with illuminating the possibilities of what can be by looking at history as a way to see perspective, with some perspective and as a predicator of what's going to happen, and then trying to demonstrate the proof of those possibilities through design projects. So as a way of starting to organize this, this is a diagram I show to my students a lot. And the way that my work starts to classify is looking at how materials influence tools and geometry and how these things work in tandem with one another. So looking at the first topic of material, and particularly looking at ideas of material volition and material agency. A good point of reference, I think, for this is Charles and Ray Eames, and starting to ask the question, what are the ways design practice is informed by materials? So with Charles and Ray Eames, they were commissioned during World War II by the US Navy for the mass production and ease of transport for a leg splint, which later impacted their designs for molding plywood and furniture. So I think what's important about this kind of work is their access to technology and manufacturing facilities that later influence their furniture designs, but also as a reference, what's important here is looking at the body and human recovery as a driver for material, tooling, and geometric exploration. So with this first project, I worked on while a student here at Georgia Tech with some of my cohorts, and we were asking what is the availability of resources and how does that impact design decisions? So we're asked to produce an exhibit to represent the student work going on, and we didn't want to do a mere kind of representation of the work, but rather a demonstration of it. So in a collaborative effort of design and making, we asked what might constitute a responsible contribution to the convention's ephemeral display of architecture and production. So what locally available materials, what organization of labor and know-how could best represent the spirit of architectural education of Georgia Tech. So rescuing 50,000 sheets of paper from the campus recycling bins, a fraction of the hundreds of thousands that are printed here each month, a singular unit of construction was derived of a simple rolled sheet. We tested its kind of structural logic and assembly and evaluated its visual coherence. And this was kind of the resulting piece within the setting of the conference. So as part of this, we worked with Matthew Schwartz, who I don't know if he's still here, but to produce this simulation to approximate the number of rolled sheets that would be needed for the exhibit. So even early on in some of this work as a student, there were a lot of questions of kind of the quantitative versus the qualitative. So trying to simulate and predict what might happen, but then also being aware of the kind of unquantifiable aspects of the aggregation of this immense amount of paper. And we'll see that as sort of a paradigm throughout the work. This next project I worked on as a research assistant under Tristan, and it was part of an Emerging Voices exhibit. And I think one of the kind of key questions that we were asking here with the DuPont sponsorship for their solid surface material, Corian, was what are the ways materials are constrained or misrepresented by how we model and simulate them? Sometimes it's simply a matter of understanding that with the properties of the material and how you can heat it, you're able to produce this range of curvature. So the project involved testing and thermoforming these pieces to create a collection of panels that gradually change in degree of curvature. So each panel was made with a CNC routed mold, thermoformed with a Corian sheet on top, and then placed back onto the mold and trimmed down with the router. So some of the images as part of that exhibit. So give them to you, okay. So as part of this too, I think that starts to address this idea of material agency. What are our kind of available resources and how might we rethink materials? But this next topic of material volition is of particular interest in trying to mediate between material volition and computational control. So the Objects of Rotation project strives to continue the evolution of providing new opportunities and digital tools for the production of ceramics. And it tries to bring together the contradictory qualities of perceived digital control with a process that has traditionally been dependent on human touch, sensitivity, and innate responsiveness to material production and craft. So I worked on this project with some of my cohorts while at the GSD, and we were really interested in the kind of rich history of how ceramics have played in terms of innovation and evolution of human progress. So understanding ceramics in the place of the home with vessels and stoves, and the development of machinery and industry through the production of the kiln and the potter's wheel and its role in architecture from the primitive hut to the forms of Antonio Gaudí. So these were kind of a lot of thoughts that were in our mind as we started the project and began to interface the robot with the wheel. And as part of that process, we developed a series of predictions of what we might be able to produce, and then a series of paper tests to start to calibrate the timing of the wheel with the movement of the robotic arm, and then the resulting clay cylinders. So as part of this, we were interested in using traditional tools and automation strategy and bringing those in with automation strategies. So looking at the same way you might think of kind of CNC, or even it's working similar to how a lathe would work, and developing a series of tool paths that would start to create different kind of responses. And then as part of this, we developed an interface where you could put in a desired input and pattern and output the machine code. And then what became really important was creating a series of challenges. So to get that kind of timing and sync, we asked, well, how might we just draw a simple line while the wheel was in motion? And then move forward to develop more kind of complex patterns. So it strives to bring an opportunistic approach to design research by exploring the potential of ceramics as a malleable material, but integrating ceramic traditions and tools with robotic technology. So it's seeking to establish a connection between craft-based processes and digital fabrication techniques, but strives to provide design opportunities through the development of new tools for production. And we were interested in how we might start to kind of predict some of these material qualities, but then understand how much of it was just the will of the material too. So in relation to these ideas of material volition, this next project starts to ask, how do materials and tools constrain one another, and what are the opportunities of potentially using a kind of stochastic material process with machine control. So we began with a series of material tests which led to the development of a 3D printer, which uses gravity as the z-axis to capture opportune moments for material fluidity. So here we're showing some of the kind of early tests of what we were trying to accomplish, and then pairing those kind of moments of volition to then the kind of hard numbers of the system, and then once again creating these kind of challenges of how do we get the material to even just stand and support itself. So there's this idea of soft computing that starts to come into play. So soft computing has to do with a collection of methodologies which aim to exploit a tolerance or imprecision. So there's a bit of uncertainty or partial truth. So similarly to how architecture, we're kind of questioning how it might also permit for some level of imprecision or uncertainty or chance, and engage with material volition, but also kind of understand the rigid order of computational control. So there's the hard numbers versus kind of the soft qualities of a material animated by gravity, and some of the results from that printer. And then moving on to some of my student work, this is some of the work going on in a fourth-year studio at Ball State University. I'm really interested in integrating ideas of design research into the studio setting, and the title for the course is Material Animation, where we're focusing on ideas of responsive materials and how to represent those ideas through time-based mappings. So we're investigating the word animation, which comes from the Latin animare, to instill with life. So similarly to how creating an illusion of movement in animation is central to conveying that something is alive, the animation techniques in the studio are trying to bring to life the approaches for kind of environmental responsiveness, advanced construction processes, and real-time computer interaction through unique material systems. This is wax and water. So the horizon of the class is bounded by the physics of the materials themselves. The rules of material change, bending radii, elastic limits, viscosity are instrumental in testing and inform the geometric laws and instrumental rules that shape innovative design. So looking at this idea of time in relation to animation, it's also really important in terms of the ideas of application that they're starting to explore. So asking how we might start to look at time at various scales, how material might respond to the tides over the course of the day, or even how it might respond to kind of the unknowing process of the rising of sea level as a kind of resilient response to those conditions. So I think some of the key questions within the studio are how can we draw on the related talents of architects, such as the power of observation and creative use of imagination, to develop work which informs and employs these talents towards research and practice. So what are the ways design research can promote a greater understanding of materiality, not only to allow us to better employ traditional materials, but also to embrace the possibilities of new ones? So once again, this notion of the challenge becomes really important within the class, asking, how might a fluid and malleable material start to take on a geometry of a rigid and rectilinear form or controlled pattern? So the students are looking at the potential applications for these studies and trying to think of how materials that respond to temperature, light, humidity, and moisture might to start to take on different types of applications. So precedents for this type of work that are going on right now include the work of Self-Assembly Lab at MIT or Bloom by Doris Kim Sung. So students are defining the principles and methodology in order to develop a formal and performative vocabulary. They set their materials into motion through a guided narrative of experimentation and application for their final projects. So materials with fingerprints are of particular interest to the class, that they're embedded with identity and are kind of a key moment of interest. So they have a certain amount of control, but there's a bit of predictability to engage with that element of chance. So we're imagining a digitally controlled scenario in which target characteristics are predictable, but the specific execution and goals are not. So once again, this notion of soft computing comes into play. Softness not only in relation to maybe some of the materials that you've seen in this section of paper and wax and various things, but and adaptable and formable, but also soft as in allowing for moments of change. So currently what's going on in terms of robotics right now, we hear this kind of term soft robotics, which has to do with integrating kind of a material logic into robotics. So being responsive without motors or actuators, and these are kind of key questions that we're starting to ask. So moving on to the second kind of category of instrumental knowledge. It's about adopting the machine as a theoretical way of kind of framing the research. So not just simply in terms of fabrication and construction machines, but it's also seeking to explore the way that machines can alter perception and help us share information and influence conceptual approaches to design. So I think throughout this conversation of the machine and architecture, it's really important to understand the kind of rich history of the machine and its relationship to design and translation. So here you can start to see the long tradition of architects who use instrumental knowledge, ranging from some of the kind of geometric drawing devices for instruments to those that we know of with even more kind of construction-based machines and tools, such as Brunelleschi's design of specialized hoists and jigs and lifts for his dome in Florence. So here you can start to see how some of these machines work, such as the conchoidograph. This is a later version, but this particular drawing device is thought to have dated back to ancient Greece and used for the description of the vertical profiles of classical columns and their kind of fluting geometry in order to achieve that. So, and then, looking at as the kind of development of machine knowledge progress, even in the kind of 1927 when the machine, this complex arrangement of pulleys and gears with the William Riggs machine actually was able to produce some of the kind of most complex curves, some of which could take up to 2 years to draw. So I think all of that started to kind of make me question machine knowledge and architecture and led to the production of my own drawing machine and starting to study the relationship between geometry and mechanical means. So drawing with linkage configuration, but using kind of a computational analysis of that. So here you can start to see there was an understanding of the physical and the digital domains and starting to try to visualize the kinematic consequences of the machine. So it's asking how do we kind of compute the idiosyncrasies and physics behind machines. So here are some of the resulting physical drawings. And then here the simulation and the digital. So the tangent lines to the curve here show changes in velocity or torque of that linkage as the motor is hesitating in kind of key moments. So I was trying to understand the difference between those kind of crucial moments of machine control and what we think is happening versus somewhat of the kind of unpredictable. And then similarly, this drawing's representing that change in velocity and torque except with perpendicular lines to the curve. And then moving forward, this next project was also produced with some of my cohorts at Georgia Tech, one who's in the audience currently. And it was a design build project that involved making a temporary installation for the decor event in New Orleans. So upon receiving invitation for the event, we worked to produce an installation that would act as a representation of our work going on in the studio at Georgia Tech. So it acted as a model of an ecosystem that consisted of a flexible modular system of units that could parametrically adjust to take on a series of different programmatic conditions. So here you can start to see some of those conditions where the modules start to include water collection, light aperture, foundation modules, and plant and air filters. So each of the 268 modules for the pavilion were made of PETG, which is a thermal plastic that allows you to easily vacuum and thermal form it. And each had a unique mold and a bolt and nut connection that it was held together with. So there were 3 ways of forming the panel. The first was with droop forming, just by heating the panel and then letting it sag. The second was with thermal forming, heating it and then overlaying it onto the mold. And then the third was through vacuum forming. So heating it and turning on the vacuum to get a really snug fit. So we were questioning how we might develop a flexible mold strategy using springs, adjustable parts, but with the availability of resources, we kind of had to resort to wood. And here you can start to see that forming process of a base, a PVC pipe, and then a top. And we had a catalog of these things that would allow us to assemble them in various ways. So the PETG was routed, placed into this fixed position, heated, and then pushed down onto the mold. So I think this relates back to kind of looking at the rich traditions of architects to make their own tools to help realize and actualize their designs. So this next project is some of my ongoing research that's asking what opportunities will arise from bringing together a change of state material with a digitally controlled and manipulated flexible mold. So these are early analog studies just trying to understand kind of the process of fabric casting, but later led to the development of this pin mold, which I think relates back to Gaudi and the hanging chain models and understanding this inversion process. So here you can see how the pin mold is automated and pushed into place, and then fabric is laid onto top, and then a cast is done to create a range of curvature. And here's some of the simulations showing and approximating how the machine's going to respond, and then the actual strategy with the robot. So the kind of crucial aspect of the mold is the rubber clutch layer, which is what's holding each pen in place and allowing it to adjust and change to create these series of different conditions. And here's a detail of that. So it becomes about a ratio of the weight of the pen to the amount of rubber that you need. And then another question became, well, you know, if there's a bit of wrinkling or whatnot in the fabric as part of the cast, how do we start to simulate that within the computer? How much of it is simulatable? How much it is just the kind of will and nature of the material? And here's some of the results. You know, there's obviously much more, but these are just showing a few of the results of what can be accomplished with the mold. And then another kind of parameter that you can start to look at is the actual pour level at which you're starting to pour the plaster. So while there's an interest here in the highly quantifiable and computable aspects of the machine, on the other hand, there's an interest in trying to capture the gentleness and the mesmerizing cinematic poetry of machine control. This relates back to the Eames again, looking at their interest in cinema and the Babbage's difference machine and how they were seeking to capture the lulling satisfaction of machine control. And then with some of my student work in my seminar currently, they're being introduced to computational thinking, but they're asked to develop their own tools for the robot based on their material studies. So once again, asking kind of how materials and tools constrain one another. And as they're developing these studies, for instance, this one is looking at the chemical corrosion of foam using acetone and trying to start to parameterize those things with a number of drops and the result. And then as they're kind of, one of their assignments for this was drawing with the robot to create a diagram for how they might develop that tooling. This is also introducing them to understanding the position within space and understanding the amount of pressure to create different line weights, but also thinking about, you know, how many numbers of drops are necessary and how might I represent that through diagram. And then there's a level of ordering lists and information to create those different line weights with these drawings, but also control the tool path so they're avoiding kind of connection between geometry. So those are kind of mostly looking at fabrication machines, but moving more to ontological machines. So this is starting to ask, what is the relationship between technology and culture? How do we re-engage a cultural project? So how do technology and design impact the way the body senses the environment? So I think today, you know, everyone probably has their cell phone immediately adjacent to them, and what we're understanding about technology is that when you leave your phone at home, you actually feel like you've lost a part of yourself. And part of what's going on is psychologically, we see our phone as an extension of the body. So with this knowledge, it's starting to question, as designers, how might we, go back to even kind of Libeskind and his early ideas of making problems with these machines themselves, and use those as a way to kind of address the technological culture that we're in. But then looking also at the kind of long tradition of architects in the body and understanding how we've used the body as a yardstick and as a scale or reference, but this is starting to ask, well, how do we really design close to the skin? And how do we understand the people that we're designing for as living, breathing, smelling, touching bodies? So it stems from the observation that the critique of most digital fabrication projects today are often really close to the scale of the body, but are not addressing the body in their designs. So this first project was an idea to create a reinterpretation of a veil, which is no longer about mourning, but operates under a new social manifestation and acts as a means for reinforcing cultural presence and identity. So the reinterpretation deals with a way of hiding as revealing a shared sense of loss, and tries to be provocative by extending out into and claiming public space in order to expose the common experience of loss. So the project draws on the traditional moments, which involve transitioning from protecting the fragile from society to connecting them with society. And these are some of the early kind of material and geometric studies that start to allow for that transformable design. So the veil acts as a social signifier, similar to how a blind person with a sight stick signifies the public a visual impairment. This signifies the need for help and the need to withdraw when closed. And when open, it signifies the willingness to communicate with others. So with this next project, Synchronous with Rhythms, it's a family of furniture that synchronizes with the rhythms of the body. So it's looking at the body's physical state of breathing, heart rate, and physiological conditions, but it's asking what are the possibilities of using technology to enhance the effective qualities of architectural spaces. So how can technologies open up the possibilities for how our bodies communicate with the environment? The project looks at the calming effects of conscious breathing and synchronized breathing. There's an interest in the effective qualities of architecture here and the possibilities of using technology to mediate between the psychological and physiological states and spaces for therapeutic or otherwise beneficial ends. So it's asking, could an object or device encourage synchronization of breath and provide a calming effect? Can technical devices be lifelike? So it attempts to provide an opportunity to feel, experience, and notice, and then begin to interact with one's body and physical sensations in an agentic and possibly self-soothing way. In her book, Galen Kranz writes about the chair and points out that the chair has been one of the most influential cultural objects in shaping our lives, and urges designers not only to rethink the design of the chair, but indicates the demand to rethink how we live, so that we can make design related to a sense of ourself and our bodies. So looking at some early full-scale prototypes, just to speculate on how this might work, which use an inflatable fabric, a relay circuit with a microcontroller and fans. So as a mode of just kind of testing these ideas at full scale. And then another prototype, similarly using a relay circuit. I think what's important here too is going back to Galen Kranz and her book. She writes, we spend much of our waking lives in the chair. We touch chairs not just with our hands, but with our whole bodies. Yet despite their intimate place in our lives, we know little about them and their effects on us, physically and mentally. Without a doubt, their efforts are profound. What is true of the chair is true of all artifacts we create. We design them, but once built, they shape us. As sitting in chairs spread to the common person over the centuries, it left a mark on the human body and the human consciousness. The chair offers a glimpse into our collective ideas about status and honor, comfort and order, beauty and efficiency, discipline and relaxation. As our ideas change, so do our chairs. So in relation to this idea of kind of conscious breathing and controlling that, there was a question of empathy and how we might transfer one's experience through breath and machine? So how might technological devices encourage empathy, which is a really important question right now in robotics with the Japanese and their elderly caregiving robots, where what they're finding is that people, while they're able to kind of address the kind of technical needs with the robot and efficiency and lifting kind of elderly people when necessary, they're not actually getting to the kind of heart of the problem, which is that people don't want empathy from machines, but they want empathy from other people. So drawing on this notion, this proposed furniture takes in 2 users and tries to encourage synchronization of breath from both users. So it's drawing from the long-standing motivation of architects to try to understand the psychological impacts of the work. And it's kind of asking how might we open the door for design exploration of the human condition and promote mindfulness through conscious breathing. And other studies, as part of the family of furniture, was trying to investigate a full range of ideas. So not just based on inflating, but how might a rocking motion based on inhaling and exhaling also start to work. So moving on to the third type of machines, which has to do with information-based machines. There's an interest here in the ideas of knowledge sharing and breaking the traditional client, architect, contractor pyramid. So for instance, with Gary Technologies and their idea for Trimble Connect, it's about this continuous flow of information, the fluidity and dynamic view of information as we see with Facebook today. That's like highly accessible and provides an opportunity for a collaborative project. So your very own Mark Simmons here talks a little bit about ideas of knowledge reuse and repurposing, intelligence and knowledge and architecture, and calls for databases that contain all design and processes of data which can be interrogated and exported to any stakeholder in a format that is meaningful to their interests and responsibilities. So questioning, where is our architectural database, and looking at databases in computer science and using the ideas behind a relational database as the one seen here, where it's about categorizing information into tables and then setting up that information in terms of relationships. So here, this is about starting to catalog and classify the history of technology and the relationship to its humanity in design projects and architecture. So it just began with kind of simply asking, where is our architectural database? What might it include? What is the knowledge culture of design? What ought it be? And asking, if we start to develop this kind of organization of information, similarly to computer science, looking at the layers and growing of information and processing of information, but refining and trying to analyze that database for errors. So checking the results of these tables and making adjustments and questioning how it's working. But then as architects, we don't kind of work with tables and data and numbers. We're not kind of inherently used to those things. So questioning how do we visualize this information and outline what types of knowledge architects have historically sought to acquire. So questioning how we might map the connections between similar ideas and how we might draw those connections. So, each mapping became about refining information based on a specific part of interest. So here, looking at time or looking at kind of parts and relationships, and hopefully trying to create a visual mapping of what our minds already do. So that it becomes an organizing structure for scholarly research where these things can grow and expand and change and adapt as our ideas change. So also looking at the kind of importance of images and that within our profession and how we might start to classify and organize those. So in a society driven by information, I think we're making decisions based on the information that's available to us and our understanding of it, and asking, well, how does that impact design, and how does it impact the way that we make design decisions? So there's a gathering of information and when we start design, right? And questioning how others have gone about making similar decisions. So what is lost in that process has really never been lost in the sciences, right? They document and they share their work. So this is starting to speculate on the notion of authorship and how we might share knowledge and information. So moving to the last category of geometry, looking at ideas of parametric thinking and mathematical knowledge. And then, of course, this wouldn't be complete without the work of your very own Lars Spybrook here and his kind of rich tradition of looking at geometry in relation to the body at the water pavilion. But this project in particular was looking at the study of body-centered cubic geometry. So looking at the molecular structure of steel, so geometry at the molecular structure, and starting to ask how these different geometries could start to create and mold space for the proposal for a children's park. So here you can see how the changing height of the body, which comes from changing position and movement through sitting, standing, crawling, etc., starts to relate to the changing scale of the units. So the visitor enters into the park by passing under ribbed canopies and stepping onto a changing and undulating modular terrain. And then this idea of kind of parametric thinking and geometric knowledge, I don't think would be kind of complete with me speaking about my work without addressing my own kind of thesis project here at Georgia Tech. So emerging from the research agenda that investigated the concept of digital craft and the study of the natural processes of bird nesting as a way of studying existing patterns and relationships that are inherently digital and parametric. So these studies looked at the variations in nest elements or figures, such as long blades of grass or twigs, and the relationships with those figures, which form different types of configurations. So it's about kind of the hard numbers, as you can see here, the counting of elements and the movement of overlap and intersection with one another, and maintaining those rules while deviating from the kind of tradition of the nest. So parameterizing those rules and mediating between physical and digital media, and then thinking about how those different variations might start to relate to solar shading strategies. So while there's this emphasis on maybe the hard numbers, the proposal also was looking at the nest not only in terms of pattern, but looking at it as a way of becoming and disappearing and nurturing for new life. So it influenced this proposal for a New Orleans Bereavement Community Center in the aftermath of Hurricane Katrina. So the Bereavement Center provides a place where people are able to show their fragility, imperfections, and weaknesses, and it acts as a place of refuge, while formally the structure reminds the community of its function, as it appears to be reaching and stretching skyward, potentially expressing how those within are longing and reaching for those they have lost. So while the nest is inherently parametric and pattern-based, there's this idea of the kind of cyclical process. So looking at the parametric versus the empathetic, the computable versus the incomputable kind of capacity of one's own life and knowing how long it will last. So this next project I worked on with some of my cohorts at the GSD, and it was purely a kind of geometric analysis and critical evaluation of Uhrenhauer's Design 1. So here you can see Uhrenhauer's Design 1 project. So we began by kind of understanding it as being broken down and as a repeated module. And then based on that module, we realized it was made up of two handles, one coming from above and one coming from below. And then we started to understand how within that module it was kind of confined to a square, and we began questioning what opportunities might arise from kind of breaking that constraint and changing those handles accordingly to allow for different tessellation. And then looking at how it's always based on kind of a central condition and how we might start to shift that center in some way to allow for more variation. And then also looking at the width of the handle and the opportunity to start to change that as a parameter to allow for different degrees of enclosure. And then as a critique, looking at the image, it's always pinned from above or below, so how might we provide a double wall cross brace structure to allow for the module itself to become structural? And then questioning how those parameters start to kind of come together and what their influence on light quality might be and how we might be able to kind of accomplish a full kind of range of variation based on those parameters. And here's some of the early kind of 3D print studies, which later led to the development of a large 3D print, which was then used to produce a rubber mold, which we could then kind of cast over and over again. And here's showing the process of that mold and taking it apart to get the final cast. And then this next collection of projects is some of my student work, which is asking how might we use the mathematical model as a catalyst for the design problem. So looking at key historical moments when the manipulation of material and architectural form induced the use of the computer, such as with the complex kind of folded structures of Ron Resch. So each student was given a key player, Joseph Albers, computational origami, Ron Resch, origami tessellations, Gaspard Munge, ruled surface, and so on, and asked to deviate from that in some way. So there's another kind of example of here looking at the methods of shipbuilding and the technique of lofting, of using kind of pins and strips to control range of curvature, which inherently relates back to NURBS-based modeling in relation to the spline. And then, moving on to kind of ideas of practice outside of research, I've managed to find myself in a kind of unique situation in this topic of unconventional practice, where I've had the opportunity to work as somewhat of a consultant, coming in, working for Plexus R&D. They're located across from the Optimist here in Atlanta, and this is their office. And they called me in because they had done this bartering with a fabricator. They had designed his house for him for free, and the event that they would kind of exchange his own, knowledge and labor with them. So they wanted to fabricate a stair, but then also some sort of shelving to hold all of the different samples and things in their office. So I came on to kind of design and work on this project within a short summer, and these are some of the drawings that I left so that it could be kind of like easily constructed with the fabricator without any questions or kind of concern. So primarily the structure is with a laminated wood beam running down the center, as you can see here, and these are some of the drawings showing the parts of assembly. And then as another project that I worked on with them, these were a couple of renderings that I received that was asking, how might we start to kind of fabricate something like this? What are some ideas you have? How might we alter the design a little bit too? Because they had sold the client on this idea of the bait ball, because it was a sushi restaurant, and the client really liked this idea of these different kind of collection spaces and how they might kind of relate to this notion of the bait ball of these fish swimming in schools. So here you can see some of the proposals I had about creating kind of a waffle structure, which then would hold up all of these panels that could rotate and change. That was the hostess stand, and then this one would go above the sushi bar. And then next, of course, the work that I've done with Formation Studio. And I think here you really start to see the aggregation of material, machine, and geometric knowledge coming together. So in order to have those kind of conversations that were necessary with the fabricator. So I came on board at the construction documents and pricing phase of the project, and later worked to produce a full set of shop drawings. So here, there was a level of kind of indexing and refining that was necessary for fabrication and assembly, and understanding the limitations of the fabricator, such as the 10-foot length of the bed that the water jet cutter was capable of. So it involved kind of breaking each beam into parts, and then understanding the HSS, which would hold all of the ribs into place to create the twisting structure, and then the skin would be welded to those ribs. So here you can start to see one of those 10-foot sections changing. And then once again, that kind of conversation of trying to minimize error and develop ways of indexing, this tab and slot connection was really crucial in the development of that, and then working with the kind of structural engineer who specified a stitch weld and the results of some of that. So, in closing, I think this diagram is really crucial to what I keep coming back to. And, as a technologist, I think it's important to understand what it means when we're talking about technology. And Heidegger, in his question concerning technology, tells us we need to get back to the root word of technology, which comes from the Greek techne. And he says techne is the name not only for the activities and skills of the craftsman, but also for the arts and the mind of fine arts. Techne belongs to bringing forth, to poesis. It is something poetic. It reveals whatever does not bring itself forth and does not yet lie here before us. So the goal within my own research and teaching and practice isn't for techniques of the techniques themselves, but an innovation and engaging in a cultural project. So while I oftentimes operate as a technologist and a designer, I try to remember and come back to this notion of techne. And this is where you start to see the paradigms that I mentioned within my work of the computable versus the incomputable, the hard numbers and hard computing versus soft computing, the difference between man and machine, digital and analog, robotic and empathetic, quantitative and qualitative. So I think based on this, and in closing, I would like to put forth a trajectory and title for where my practice is going in terms of research and design and computation, and incorporates this notion of softness. So softness not only pertaining, like I said, to maybe a material quality, but in regards to soft computing and tolerances and chance, qualitative experience, empathy, the body, and this notion of techne, and addressing Heidegger's idea that it must be neither technological nor instrumental. Hashtag huggable architecture. So my research seeks to investigate the potential for material and machine knowledge in architecture. However, it wants to understand technology not just, and machines not purely as material manipulation, but as instruments which affect people and their environments. So the intent is to go back to techne and to uncover design approaches which demonstrate the influential capacity to impact and enhance the lives of those who encounter it. Thank you. Questions?
So I'll just start by saying that was a brilliant sort of panorama of an extraordinary body of work. It was not only beautiful work, but it was also kind of deeply reflective on, theorizing, and it was really brilliant lecture. So I'm sure there are questions and comments.
Yeah.
So as an engineer and a technologist,
Mm-hmm.
I'm sure you like that. How do you tackle the fear of software literacy or technology literacy that's been taking over as opposed to teaching students? Behind using technology, so you were doing the hot rising cold water, which is manual on a 3D printer, whereas students are being pushed to learn to 3D printer without understanding its application for applications.
Right. You know, in the instance of the kind of example that you're talking about, I think in that class, there's a pairing of the kind of analog studies, but also this aspect of the digital. So they're having to learn software they're completely unfamiliar with, like After Effects, for instance. And I think there is a bit of resistance, like you're saying, that you get from that kind of thing. But what's really important within that is, I think, to foster kind of some confidence with the students. So that's a much larger question in terms of teaching, is how do you kind of create a confidence and encourage creativity, right? So this notion of the kind of collaborative studio is so important, right? Within that and learning and dealing with software, because you know, I think the days when I've come into studio and I find them all hovering around somebody's computer is like the day that I know they're learning, right? Because it's not just about me kind of teaching, but them learning from each other and realizing, oh, hey, you did that. How did you do that? Tell me, like, let's have a conversation, let's learn, let's collaborate. And that's why, you know, it's so important to kind of be in studio working and making things and learning from each other. Any other questions? Yeah.
For the, I guess it's a steel project art, children's art, what level of molecular was it?
It was just looking at bodied-centered cubic geometry. So it began from just a material investigation. We were asked to investigate a material, and we looked at steel in particular, and then looking at the kind of nature of steel as bodied-centered cubic, and then starting to look at that as a reference of geometry, and you know, creating a series of tetrahedrons and I didn't show as much of that, but then breaking that down and unfolding it to kind of create the ideas behind the overall form.
determinacy and soft computing.
Mm-hmm.
A lot of it's related to, I guess, material properties or construction world.
Mm-hmm.
Do you see this maybe in the future, like in a meaningful way, actually start to program indeterminacy? Like, how would that?
Yeah, I mean, that's a really interesting question for sure.
But actually, like, giving peers the option, the error.
Yeah. I mean, that's a really interesting question, and I think it's probably a kind of rich question in computing these days. But in terms of design, it's even, I think, a more interesting question of how do we design with indeterminacy, right? Or this element of chance, right? Where I think, you know, the way that we traditionally think of materials is that they're always dimensional, right? But then how might we engage in a material that has its own kind of will based on a specific process that we're interested in? And I think, you know, with printing techniques and fabrication and whatnot, it could be an interesting kind of pairing to start to engage that.
But the work with someone like Carl Shu at Columbia and generative algorithms, I think deals with that question. You know, because indeterminacy, once you code it, it's still indeterminacy,
Yeah.
right? Or is it just variation?
Right.
And that's the.
And it's the same when you work in parametrics, right? You're actually kind of coding in what you can control in some way. So it's predetermined based on how you're loading that model.
For me, the brilliance of this work is to say, how do you set up a boundary condition, and maybe a variable boundary condition, and then those are the kind of hard constraints, and I'm just giving my project work, and then you allow the material to be the kind of softer infill condition, which animates the system. So that kind of hard, soft interplay, or, you know, frame, fill, interplay, I don't know. Maybe there are lots of ways that we can start to think about how you know, that thinking would inform design and the scale of buildings even.
Or even in your studio, you have NASA coming, right? And what does it mean to kind of work in an anti-gravity
Right.
condition?
We had a guy from Michigan down recently, and he was doing a kind of internship between the practice and Rouge Tech. And his thesis project was all about using flexible formwork and gravity as a kind of infill animating condition for concrete. But then a lot, I mean, and that's kind of well known, right, how that works. But then a lot of what he was focusing on too was how to develop edge condition for interlocking between the panels. So it was really interesting. He was thinking about the hardcore construction logic of actual buildings, but then this softer, more playful, animated condition of fabric formwork and gravity, et cetera, et cetera.
Any other questions? Everyone have studio now?
Well, Rachel, thank you so much for coming and sharing your work. It was a brilliant lecture, very thoughtful. Thanks.
Yeah, thanks.